So hi guys.
Hey, I think we're live. So thanks everybody for day 3 of the J Champions conference. I think this is what the second session of the day, or third session of the day, something like that. So we've got Mario here, who's going to talk a little bit about some AI stuff. Please, just some housekeeping before I turn it over. Feel free to post your questions. I'll throw them on, or I'll interrupt as questions arise. But other than that, have fun, enjoy the talk. I'm looking forward to seeing this as well. So here you go, Mario.
Okay, thanks, Eric. My name is Mario Fusco. I work for Red Hat. I'm a principal software engineer at Red Hat, and I'm the project lead of Druze, which is our historical rule engine. And but these days I'm also one of the contributor of the LangChain4j libraries and also of Quarkus, and mostly again on the integration of the Quarkus extension with LangChain4j. So I'm on both sides of the things that I'm about to discuss with you today. And by the way, please feel free to ask question, and Eric, feel free to interrupt me if there is any question. So the idea about this talk is to demonstrate how to mix generative AI and machine learning and all the new cool stuff with some other, let's say, older technologies like rule engine and or similar tool, and why you should be do this. Okay, so I think you can see my screen, right? So yeah, why not machine learning alone? I mean, it's the new cool kids. Everybody are doing generative AI, and so why are not we using just machine learning? I believe the main reason, the main answer to this question is that machine learning is a bunch of statistical algorithm that are doing really crazy and amazing thing. I mean, from time to time, I really jump from my seat, being impressed of what this thing can do. But the reality is that since they are a mix of just a statistical technique, they are totally unaware of the business domain. My dog is not doesn't agree. Sorry, but sorry. What happens is that, okay, in this example, this is something that happens to me a few months ago. I was buying a washing machine on Amazon, and then it suggested me, maybe you want to buy 3 more washing machine. Why? Just because those products are all statistically related, and I don't know, Amazon decided that either I want to put up a whole new laundry, or this doesn't make any sense under a business point of view. Under a simply human point of view, it's very unlikely that if I bought a washing machine last week, I'm going to buy another 1 or 3 more this week, right? And it's important to make a distinction on the terminology, I believe, meaning that we often use in an interchangeable way the terms artificial intelligence and machine learning and maybe deep learning, but in reality, they are not really synonym. They are one is a superset of the other, meaning that with artificial intelligence, we catalog all the techniques that are about mimicking the human behavior in a way or another. So even in completely programmatic driven way or declarative way, like for a rule engine, but even, of course, by using machine learning algorithm. So machine learning is really a subset of artificial intelligence, and of course deep learning is a further subset of machine learning that is based on some technique to use deep neural network and similar statistical tool for those amazing generative result that we are discussing today, and we basically really use every day now. So it's all about naming, and sometimes it's all about fancy naming. In our environment, we are used to reinvent the wheel, giving to it different names, and this happened also to rule engine in the 80s. They were a cool thing, and they were probably called rule engine, and then in the 2000 it were not so cool anymore, so we started calling them production system that are not so cool anymore. The only thing that is cool these days is artificial intelligence, so we rebranded this thing as a symbolic artificial intelligence. And we are happy with this, and we are allowed once again to use these technologies from the 80s. So it's really a matter of naming and sometimes fancy rebranding. But in reality, as I was saying, why do we want to mix this thing? Because with machine learning, you can find, again, statistical correlation and discover maybe new patterns that you were not aware of. But in reality, all your knowledge about your business domain lies somewhere else. I mean, it's not really, I believe, something that you want to be rediscovered again in a very expensive and not very reliable way with statistical thing. I mean, it's something that you already know, and maybe you want to encode this knowledge in a proper way, for instance, in a completely programmatic way, but also using a rule engine, for instance. So as I say, in this case, both these technologies can be labeled as artificial intelligence. One of the two is machine learning, but the knowledge about your business domain lies in the algorithmic part and in the rules part. It's something that you don't want to reinvent from scratch, or making the generative AI think to reinvent from scratch. You can just simply encode it and have much more control on it, right? And in reality, there is some large studies on this. This area is generally called hybrid artificial intelligence, or neurosymbolic artificial intelligence, which is another cool name. But again, the idea is to mix these two technologies, to mix generative and symbolic artificial intelligence. And if you go on Wikipedia, you will see that there are lots of pattern around this idea. The name of these techniques is very, I don't know. It doesn't make much sense to me. I don't know why these things have been labeled this way. Probably it's really hard to find the right name for this stuff. But as you can see, there are lots of possibility to mix these two technologies. And in the demo later, we will see an example of this very last pattern when I'm trying to integrate a rule engine, where I try to integrate symbolic reasoning with a chat, an LLM, to create a business-aware chatbot. And the idea for this demo started from this news that I read a few months ago. I don't know if you heard about this, but in essence, what happened is that Air Canada had this chatbot talking to customer and explaining stuff. And among the stuff, there was the refund policy of the company. And at some point, this chatbot, while talking with a customer, completely hallucinated and told the customer that he was entitled to receive a refund of 650 Canadian dollars. Again, this was completely not due. It was a complete chatbot hallucination. But of course, the customer asked for that refund, and Air Canada refuses, telling him that the refund was not part of their policy. And guess what? The customer went to a court in front of the judge. The judge gave him right, and Air Canada was obliged to pay the hallucinated refund. And of course, the very day after, the chatbot was offline. So this is what happens when you let an LLM to drive your business completely. Okay, and this hallucination problem is not something that is going to be solved. I mean, it's something that very likely we can mitigate. We are finding pattern and strategies to mitigate this thing, like for instance, guardrails and using an LLM to control the first LLM. There are a lot of technique to mitigate this hallucination problem, but the reality is that there is no way to fix structurally fix this problem. You can work around it, you can mitigate it, and again, as I said, there are many research. For instance, this is citing an article, an internal article published here in Red Hat, and the idea here is that there are mainly two solutions to deal with hallucination. One is to use different language models, having one that control each other, basically. And another idea is, of course, using this large language model in conjunction with other technology, like for example, a rule engine, as I will demonstrate. Okay, so yeah, you don't want something that can hallucinate to drive your business. And as I anticipated, there are actually papers demonstrating that hallucination are there to stay. They cannot be totally eliminated. Okay, and thinking about this, there are a few interesting issue with these new machine learning technologies and generative AI. I'm sure that you are already confronting with it, with this, and thinking about them. One of the main problem is, of course, accountability. If this thing does something wrong, who is the responsible for the problem? I mean, think to a automatically driven car, a driverless car. If the car has an accident, who is the responsible for it? It is the provider of the machine learning algorithm driving it, is the driver, is the car manufacturer, it's not clear. And I mean, the computer and the machine learning algorithm cannot be held accountable in the end. So we need to create a set of rules and regulation that we already don't have. And there are other also ethical aspects that are hard to define in this area, in my opinion. And the other problem, of course, is the lack of transparency of most of these tools. I mean, if you ask for a mortgage and the bank cannot refuse the mortgage, the bank cannot say no just because the machine learning algorithm say no, right? It has to be, they have to give you a trackable, a transparent explanation of the refusal, and this is even more evident in other critical fields, like for example medicine. If the machine learning decided that you have a cancer, maybe you want to know why it's telling you this, and the doctor cannot just say, look, you have a cancer because the machine told us so. Okay, so there is auditability. The auditability of these tools is another issue, and under a technical point of view, however, so accountability and transparency are are important problems, of course, but are more about also mostly about ethical aspect and regulation aspect. Under my point of view, under the technical point of view, the most interesting part is that this new algorithm also introduces some way of malfunctioning that are not we are not used to deal with this kind of malfunctioning. We call them bugs, but they are not even really bugs. They are again hallucination, and to me a bug is something that, I don't know, I have a condition, I used an or instead of an and so the condition was wrong, and this created malfunctioning. I have a bug, I try to debug the problem, I break my head, I find the wrong condition, I fix it, I deploy the fix in production, and I fix the bug. I'm done. Okay, but if this thing is an hallucination, you cannot, of course, follow the same process. There is not something really to fix. You can try different models. You can play with the prompt, doing this thing that with an horrible term, in my opinion, is called prompt engineering. But there is not really something that you can fix in a algorithmic and in a 100% reliable way. It's a malfunctioning, and that you have to deal with it. And just to give you another example, in these these days, last days, it is happening that, as I said, I'm a LangChain4j contributor, and it's happening that we are experiencing with a few models that a model can call the tool by telling the server which tool they want to use, and from time to time they hallucinate on the name of the tool. They ask the LLM to use a tool that doesn't exist. Okay, and what you do in this case? You retry, you throw an exception up to the client, you give a default tool answer, you ignored all the problem and move forward. There is no a reasonable default behavior, in my opinion, or we need to think hard about this. I mean, these are totally new categories of problem that we have to face in these days. And as I said, one of the suggestions to fix this problem of hallucination is, okay, I have an LLM that may hallucinate, so guess what? I can add a second LLM that controls the first and decide if the first hallucinated or not. And yes, actually, this is not only doable, but many do this. It's somewhat reasonable. But if you think about it, this reminds me a more than 20 years old joke. At the time we were overwhelmed by XML. I believe that if you are my same age, you remember the days. And the joke at the time was that XML is like violence. If you are, it doesn't solve the problem yet, it just means that you are not using enough of it, right? And to me, this approach with LLM looks very similar. It's like violence. Keep using it until it solves the problem. Yeah, it may works, but probably we may look for other solution. Okay, so back to the original problem. If you remember, I was speaking about this problem that the chatbot of Air Canada had a few months ago. And inspired by this, I tried to find a solution in my own way. So what I had is a chatbot talking with a customer in a very human-friendly way, of course. But then when it's time to calculate to decide if this customer may or may not have a refund and what's the amount of this refund, I don't want the LLM to throw away some random numbers or some random decision. I want to control this thing precisely with the business rule of my airline company in this case, right? And in this example, I use the rules for a twofold reason. The first reason, again, is to calculate the refund amount. But the second way how I introduced the rules in this demo application is that I implemented this very, very simple state machine. Okay, maybe using rules, it's a bit over engineering for this use case, but I just wanted to demonstrate this other possibility. So what's happening, because you can have a very much more complex state machine in your application, which is quite common, and maybe you may want to use a rule engine for this thing. So what happens here, if you think about it, is that this chat with the user goes through 3 different stages. In a first stage, the chatbot should extract the data of the customer. And then when the data of the customer is complete, it can transition to the second state where it is extracting the data of the flight. And then when also all these data are complete, it can finally transition to the third state, meaning that they can put together all this data, send it to the other instance of the rule engine, the one that is supposed to calculate the refund amount and read the output of that thing. The other reason why I'm doing this is also because limiting the scope of an LLM also limits a lot the possibility of hallucination, which is the things that you want. I mean, if you give a very specific role to the LLM, it's you are reducing the possibility of hallucination. If you tell the LLM you are an airline chatbot, deal with a customer, it's a very generic task, it's a very generic role, and then it can hallucinate more. But if you tell to the LLM, okay, just try to extract the name and the age of the customer, and that's all, and then you move to a different LLM configuration where it only tries to extract the data of the flight. And then if you give it this so very limited scope, again, it's you are decreasing a lot the possibility of hallucination. Okay, so enough talk. You can find this demo together with other example in this project. But I also, of course, wanted to show you a bit of the code. Okay, first of all, let's give this a run. This is a Quarkus application integrating the truth extension and the LangChain4j extension, this time using Llama because I'm running the LLM locally through Llama, but of course there are lots of modules of LangChain4j to integrate different LLM providers. So let's give a run. Let's give a run to this thing. So I'm starting the server now. Okay, it should be up. Okay, so this is my my chatbot. Let's start chatting with this thing by simply saying hi. And while this thing is going, you can notice, of course, two things. The first thing is that I completely suck at doing front-end development. It's not my work, and I have no clue how to do this. So this is the best front end that you can expect from me. And the second thing that you can notice is that it takes quite a lot of time to respond. But again, this is simply because I'm also running the LLM locally through Llama on the same machine where I'm doing this presentation. So I will show you how this is configured. So when this thing starts, if you remember, I implemented the state machine. So when this thing starts, it is of course in the first stage of that state machine. The first stage is the customer extraction. So what the chatbot is doing is trying to ask me my data, meaning he's asking me my basically my full name and also my age. Okay, so I can tell him that my name is Mario Fusco. Okay, and just to give you an idea what's happening here, I have this customer extractor thing that is an AI service, which is configured with the Quarkus LangChain4j integration. And what this thing is supposed to do is trying to extract the information about a customer from the text that I'm giving to it. Okay, so what this thing does is actually returning the customer Pojo record in this case. What happens when you do this is that you don't have to implement anything. This interface is just a contract of how the AI service is supposed to work, and all the rest is generated, or the code is generated for you by Quarkus following this contract. So the contract is that I'm extracting some data from this text, and the data that I want to have in return is this customer object. So mostly what we do, just to be clear, is that we ask the server, the LLM server, to extract this data from the chat and put this data in a JSON format, and then automatically Quarkus deserializes this JSON format into this customer object. The problem now is that I just gave it my name, but to have a complete customer, you also need the age. So this thing cannot go transition out from the first state, from the first stage of the state machine. And okay, I'm speaking about the state machine, but this is simply how it is implemented. So I have this object that gathers the data of my session, and if in this session I don't have a customer yet, then I'm still in this extract customer stage, meaning that while I'm doing this interaction, I will use this customer extraction service. Then when the customer data will be completed, as I said, I can transition to the second stage. So I have a customer, I don't have a flight yet, so I want to extract a flight, and then based on the state machine, the system will switch using this second extractor, which is very similar to the other one, but this time it will ask me question to extract a flight record out of my jet. Okay, so I'm still, again, this thing still doesn't have my age, so let me tell him a random age. I'm telling him that I'm 70. So what should happen now is that now it has all the data to complete the customer record. So the customer object should be added to the session data, and at this point the system is ready to transition to the second stage. As you can see now, it is asking me my some information about my flight. Okay, so I can tell him that I was on flight 22 and that 4 hours of delay. Okay, so I'm also providing the data about my flight, and it is telling me that I'm entitled of a refund, and my refund should be $528. Why this amount? Because of course this is not hallucinating or inventing a random amount, but it's applying the business policy of my fictional airline company that I encoded with these other rules. So here I'm saying that I can have a refund if the delay was more than 60 minutes, than 1 hour. And then in this case, the amount is $2 for each minute of delay. And then if I'm older than 65, I'm a senior, and then in this case, I can have the 10% more. So in essence, what's doing this thing is, I told him I have 4 hours of delay, so it's 240 minutes, so it's $480 here, and then if you add the 10%, you will get the exact amount that this gives, these things gave to me. But as I said, one of the problem of this tool, if you implement it with pure machine learning algorithm, is that they are not transparent, they are not auditable. They give you a result and you don't know why. But if you apply your business rule in a very controlled way, then at this point you can also give a very reasonable explanation to the user. So let's try this. I can ask explain the refund amount. Okay, so what's happening now is that okay, now I'm at the end of the data gathering. The result has been already produced, so it's acting as a generic airline chat service. But the additional thing is that I gave to this service this explanation too. Okay, so if I ask to this an explanation to this thing, an explanation about the result, what this thing is supposed to do, again, provided that it doesn't hallucinate, is asking, is not invent anything, but asking to this thing. Okay, and this explanation tool is simply going to the session data collected by the rules while executing the rules. And in this case, I did that the explanation, it's simply the concatenation of the names of the rule. Okay, so when a rule fires, automatically the name of the rule is added to the as part of the explanation. Maybe we can see this. No, this is. I don't remember when I implemented this thing, of course. But anyway, so maybe I can show you. No, these are the data of the session. Yes, this is the state manager. Okay, this is the chat. But what happens when the rule fire? State manager, when I mean the state. Okay, I don't. I will look for it. But basically, what I'm doing is that again, I'm concatenating the. No, this is only the cache. I'm concatenating the rule that have been fired. Okay, so this concatenation of maybe it's here. Okay, yes. So this is what happens when it fires, and I'm triggering this thing and accumulating into the rule session the name of these rules. So in essence, what this thing is doing, is that is concatenating these three rules and then passing back to the LLM, and the LLM is simply rephrasing those three rules, but in essence, it's telling me what I told you before, that if the delay is more than 1 hour, then I'm eligible for a refund, and then the refund amount is $2 per minute of delay, and additionally, since I am a senior, meaning that I'm older than 65, then my refund is increased by the 10%. Okay. So let me know if you have any question about this thing. But in essence, what I'm trying to demonstrate is that with Quarkus, you can Quarkus is very nice to work as a glue code for all these extensions and put together all these tools and have a result like this.
I was gonna say, it's never happened to me where I've written some code and not been able to figure out what I wrote.
Yeah. Sorry. I wrote this a while ago, but in essence, well, this is really done automatically. It is collecting the name of the rules and putting it together in the session explanation. Yes. Is there any question?
Yeah. Amgad was asking, when would you be able to see Java competing with Python in the AI market as a developer's first choice, or do you not think that that's realistic?
Well, I have a hard time replying to this question. I haven't well understood why Python became the de facto standard for this kind of thing. Meaning that in Java you can have exactly the same possibility in a much more powerful and way, and the ecosystem is very rich and now is also pretty stable. I believe it's just because the data scientists are used to work with Python, and this, and under the data scientist point of view, probably it makes sense to work with Python. Okay, but then at some point you have this. I mean, I'm not a data scientist. Probably neither you are, or very few people in this talk we are data scientists. And if you are not a data scientist, what you do is that you don't create an LLM, but you simply use it as it is. Try to play again with the temperature, with the prompt engineering, but you use it as it is. And if you want to do this, I don't see a reason for this specific task. Integrating an existing LLM, I don't see any reason why you may want to do this in Python rather than in Java. If you have an opinion about this, just let me know. I'm really curious of the answer.
Yeah. So the next question is, could you explain?
Okay. Yes.
Configured. So
sure. So what's going on here is that I have this. So while this thing move forward to that state machine, I have this session data where I accumulate that customer returned from the customer extractor service, and the same from the flight. And at some point, okay, I say I'm ready. My session data is complete, meaning that both these objects are not null, as you can see here. At this point, I can say, okay, I'm ready to enter the third state of the state machine and calculate the refund. And then, no, sorry. Okay, this is the how the state machine works. So this is for the rule of the state machine, and this returns a chat state telling this thing in which state it is. But when it enters in the in this third state, let me do this. Okay, this is in the consequence when it enters in this third state. Okay, sorry, is this? It is now ready to calculate the refund. So what it's doing is saying create a session. Key is the umbrella name of the rules project. Create a session for this set of rule. Okay, so I have my set of rule defined here, and I'm saying that the refund calc session is related with the rule that is in this package. So these are the refund rules, and what happens here is that it is inserting the data into the session and asking for the refund and returning the refund. Okay, and okay, this is also the thing that I couldn't find before. What I'm doing while running this session is that I'm adding to the session this rules listener. This rules listener is only meant to accumulate in the session data the name of the rule that is fired. Okay, so it accumulates this rule name. So when you are at the end of the conversation and you ask for an explanation to the tool, then you have this concatenation of the three rules that are fired are concatenated automatically and use it there. Okay, so let me give you an example. If I tell to this thing that I'm 50, not 70, then this third rule will not fire. It will not add that to the session, and then you won't see it here. Okay, is this clearer?
Yeah. So then I think the next question that came out is, with the Drools engine performing the calculations and constraining, does it make sense to add RAG for the domain knowledge?
Well, RAG, it's well, RAG it's a pattern, right? To me, it has a sort of different meaning. Meaning is that to retrieve a document. Okay, here you are running a rule. I wouldn't call this thing RAG, even if I admit that the border is a bit blurred in this case. To me, RAG is to give a set of static document, a set of where the LLM can find some information for a given topic. Okay, but this is not what I'm doing here. This is not a set of static document. For example, I'm not giving to this thing the document containing the policy of the airline company. This is more a live thing. I'm using a tool. I'm using in a dynamic way. So the simplest example is that this thing, for instance, are not good to do math. So if you want to do addition, you call a tool that does the addition for you, a Java method that sum up to numbers, and then it gives you back the result, and then you use this result. This is a tool. I'm doing exactly the same way here in a more complex way with the rule engine to calculate the refund amount and provide an explanation. But I wouldn't call this RAG, because again, RAG is against a static block of document, and this is a dynamic tool. That's the difference in my opinion.
Yeah, from my own knowledge, what model, you said you're using a llama, what model are you using behind? Are you using multiple models for the different pieces?
Yeah. So this is also, in the new set of pattern that is called Agentic AI. So an agent really is any function that has an intelligent behavior, whatever it is, including summing up to numbers. Okay, so this agent AI is another fancy name, in my opinion, to say, okay, I have a set of tools. A few of these tools are implemented with an LLM. A few other of these tools are just programmatic function or implemented with a rule engine, or accessing to reading to making query to a database and stuff like this. And you put all these tools together in a orchestrated way to let them cooperate and use them together. So in essence, this is a very, very simple example of what they call agentic AI, because the rule engine in this case is one of the tools, is one of those intelligent agent that is doing a specific task, in this case calculating again the refund amount.
Cool. I guess the only other outstanding question, and I don't know if it needs more clarification, but how do you handle debug mode through LangChain for J?
Okay, so what I normally do, and this is generally enough, is that you can enable the logging. Okay, and when you do this, you have plenty of you have the complete dump of the conversation between your application and LLM. Okay, so here let me give you one example. Here I'm telling this thing to, if you remember, provide an explanation, and this is telling it that it can use this tool if necessary, if it is required to wait for an explanation. So this is all in JSON. This is what you are sending to to the LLM. So you see the system message, you see the user message, you see the set of tools that you are providing with the specific AI service, and then you see the reply of the tool and the final output. So this is already quite. It's a little bit verbose, of course, but you have a complete track of what's going on the conversation. So this is the best thing you can do, in my opinion. You don't really want to get to debug a LangChain4j, I believe, unless you don't have a very good reason to do so.
I guess one question I have for you, because I've worked with Olama and some of these models and tools and stuff before. I find when I have tools, like it calls them when I ask them to, but it also calls them a lot when I don't want them to. Like, how have you seen that, and how do you get around that?
Yeah, this is related with the hallucinations problem that I was mentioning before, and we are working. Or again, it happens that it asks to use a tool that doesn't exist at all. It's quite common these days. I don't know why, and I don't have a clear answer for this case. You can try to reprompt again the same question, hoping that it will work now. Or I really don't know. The other tool that I suggest you to give a look if you want to deal with hallucination is that in the Quarkus extension we have this tool that is called Guardrails, and in reality we are about to bring this thing in the back into LangChain4j. Okay, so guardrails are a tool to have control both on input and on output, and for the input part you want to control what you are sending to the LLM, for instance, to prevent injection attack typically. And for what regards the return, you want to have more control on the LLM output, for instance, to prevent hallucination. One of the example, one way of how I used this guardrail thing is that I told you in my example that how the way it extracts Pojo from the conversation is that you ask to the LLM to replies exclusively with a JSON containing the data, and then Quarkus automatically deserializes those JSON data into a Pojo. But what happens very frequently is that the LLM hallucinates and tells you person Mario, age 18, and then it appends some random string to this JSON. Say, I told you that Mario is 18 because you told me that it just became adult. It adds some random explanation, totally unrequested, but it happens. So what you want to do in this case is to sanitize, let's say, the response of the LLM to only extract the JSON part and pass it through to the serializer. So what Quarkus gives you out of the box is that you can use this output, you can extend this output guardrails, that this sanitization for you, trying to just simply use a sort of regular expression to extract the JSON part from a bigger string. And then, okay, this is exactly my example with the customer. And then you simply extend these base class provided by Quarkus with this thing, just to say, okay, I want to sanitize something that will be unmarshaled into a customer class in my case. And then if you use this guardrail, you are guaranteed that the JSON the serialization part, well, it's not hallucinated. It may come hallucinated from LLM, but you have a layer to sanitize it before passing it through. So this is another tool to deal with hallucination.
Yeah, I find a lot too. Like if I ask it for JSON, it's like, here's your JSON, and then it gives it to me in Markdown, right? Like tick, tick, tick.
Okay. Okay. Yeah, that's.
So you can use it for that too.
Yeah, it also depends a lot. It also depends a lot on the model that you are using. So if you are using a model that suffer of this problem and you are aware of this, the thing you can do is having implementing your own guardrails that does this, that in your case translate the markdown into JSON before passing it forward. So
cool. Yeah, I don't think there are any more questions. So I don't know if you have more of your presentation or if you're.
I'm usually running out of time, and I believe that people want to follow something else. Thanks a lot for the question. I have some. Okay, here I was playing with ChatGPT, asking for other situation where you may want to mix generative AI with a rule engine, and of course he gave me a few possible use cases. The very first one is the one that I implemented, is the customer support chatbots, and there are lots of interesting other one. For instance, I'm intrigued by this smart home automation thing, which is something that could be another cool demo, in my opinion. And yes, I have a second part giving you an hint on how we are trying to mix in a different way machine learning and rule engine, but probably we can skip this and ping me if you have any, if you're curious about this. The conclusion are that, again, generative AI and machine learning are only a fraction of the whole AI story. There are many more things that you can do to mimicking the human behavior in a reasonable way, and it's usual thing. It's an hammer, and if you have a nails, you want to hammer it. If you have a screw, probably you want to, and you have a toolbox, and you have to use the right tools for the job at end. And calculating the refund amount for an airline company probably is not the right job for an LLM. So again, it's one more tool in your toolbox, and use it knowing the pros and cons and the limitation of your tool. And the other message that I had is that I really believe that machine learning is very complementary with rule engine or workflow engine or symbolic reasoning in general. And it could be a nice idea to experiment more with this thing that, again, they call the narrow symbolic AI, which is another probably fancy name. But the applications are very interesting.
Cool. I guess if there's not any other questions, is that all you got? Is that all, folks? Or any other questions for Mario while we have him here? I appreciate his time. Mario and I were chatting a little bit before this, and chatting about all the kind of the different things going on out there. And to me, like, this whole AI space is moving so fast. Like, I was at a couple user groups last week and talking about AI. Like, if I'd done it the week before, it would have been like, oh, that's so last week. Like, it moves so fast. So trying to keep up to date with everything, I think, is hard and super important as well. So, but thank you, Mario. Thank you, everybody, for attending. And stay tuned. I don't know which session's up next, but there's another great session coming up with J Champions Conference. And thanks for attending. And thanks again, Mario.
Bye all. Thank you.